Okay, so electric current is the flow of electric charge, and the wires and the filament in this circuit are made of metal. So the metal is full of millions and billions of free electrons, and those electrons have a negative charge. Now there's no current flowing in this circuit at the moment, but if I close the switch, then electrons will start to flow around the circuit. And because the electrons have got a negative charge, that means current is flowing around the circuit. Now you've got to imagine there's not just one electron going around this circuit, but millions, billions of electrons throughout all of the wire flowing around the circuit. So when the switch is closed, current flows. Now we can measure the current using an ammeter. So if I put an ammeter in the circuit, the role of the ammeter is to measure the current. Now the ammeter is measuring how much charge flows through it per second. So you could kind of imagine this as the number of electrons flowing through per second. And you've got to imagine that these wires are full of millions and billions of electrons. So the ammeter is measuring how much charge goes through it per second. But charge isn't the same as the number of electrons. You'd actually need, thousands, millions, billions of electrons to make up 1 coulomb of charge. So the ammeter isn't reading you how many electrons go through per second, it's reading how much charge goes through per second, measured in coulombs. So if we add another cell into this circuit, the electrons are going to start flowing a bit faster, and the ammeter is going to measure more charge passing through it per second, and therefore it's going to read a higher current. So current is the amount of charge flowing through the ammeter per second, where charge is measured in coulombs.